Okay, so let's start solving the prepared sample problems intended for review of our major exam. Let's start first with number 1. A strip of magnesium metal is treated with an excess of concentrated nitric acid, meaning there is already an excess. We already know that magnesium metal is our limiting. If 125 milligrams of magnesium is consumed, determine the mass of the magnesium nitrate formed. Okay, so 125 grams of magnesium metal. So magnesium is 24 grams per mole times the reacting ratio is 1 magnesium is magnesium nitrate. 1 magnesium nitrate. So 1:1 magnesium nitrate times 1 mole of magnesium nitrate is how many grams? Okay, magnesium is 24, nitrate is NO, okay, times 3 times 1, then times 2 because dalawa. Okay, nitrogen is 14 times 2, that is 28. Oxygen is 16 times 3 times 2, 96. 28 plus 96 is 124. 148 per mole ang ating magnesium nitrate. 1 magnesium, 2 nitrogen, 6 oxygen. Tama. Okay. 148 gram per mole. 125 divided by 24 times 148. So it is, a lot. 770.83 grams of magnesium nitrate. 125 divided by 24, yeah, it's because it's magnesium metal. 1:1. Then 1, yeah, looks great. Next, balance the single displacement reaction. Okay, so how many sulfate is there? There is 3 sulfate na kailangan. 3. Then, dalawang chromium. Ilang silver? 6. 6. Let's check. Chromium is 2. Silver is 6. Sulfate is 4. Chromium is 2. Silver is 6. Sulfate is 4. Take note that multivalent ions can behave as one unit. Hence, I'm counting sulfate, not sulfur and oxygen. So that is balanced. 2 Cr, 3 Ag2, SO4, Cr2, SO43 plus 6 silver. That's the balanced chemical equation. Are we recording? Yeah. Check lang. Next, in a precipitation setup, 310 grams of barium chloride is reacted with potassium sulfate. The products are barium sulfate and potassium chloride. Identify the limiting, excess, and compute the theoretical mass. First, before we start, let's compute for their molecular weights. K2SO4. And finally is barium sulfate. Barium is 1. Chloride is 2 times, what is barium? 137. Chloride 35 times 2. So 137 plus 70. 137 plus 70. 207. Barium chloride is 207 grams. Potassium sulfate, K is 2. Sulfate is toxic. Okay. 214. 214. Potassium is 39. Sulfur is 32. Oxygen is 16. 2 times 39 plus 1 times 32 plus 4 times 16. 174. Then barium sulfate is 137 plus sulfate is 32 plus 4 times 16. 96 plus 137, 233. Okay, now let's balance the chemical equation first. Barium chloride plus K2SO4 is barium sulfate plus potassium chloride. If we have 2 potassium chlorides here, balance one barium, 1 sulfate, 2 potassium, 2 chloride. So it's 1:1 basically. Okay, so let's start. 310 grams barium chloride. Then the other one is 215 grams potassium sulfate. Okay, next is barium chloride is 207 gram per mole. Barium chloride 215, 174 gram per mole. K2SO4. It is a 1:1 ratio with barium chloride. So 1 barium chloride is 1 barium sulfate. Same here. 1 potassium sulfate is 1 barium sulfate. Times. Then finally, 1 barium sulfate is 233 grams. 1 barium sulfate is 233 grams. 310 divided 207 times 233, 348 grams. 215 divided 174 times 233, 287. So this is the limiting and this is the theoretical yield. This is the excess. Next, a pharmacist combines 420 ml of 0.650 molar acetic acid with 780 ml of 980 molar acetic acid to make the stock solution. Calculate the total grams of acetic acid present in the final mixture. Okay, so remember that molarity is moles per liter. If you're not in liters, ml to liter is divided by 1000. So you have 0.650 moles per liter times 420 ml divided by 1000. This is to make liters. So this is 0.650 times 0.420. We have 0.273 moles from the first solution. The second one, 0.980 moles per liter times how many? 780 ml divided by 1000. 0.980 divided times 0.78. That is 0.7644. 0.7644. We add that together plus 0.273. So the total moles in the solution is 1.0374 moles. But what it's asking is acetic acid. grams of acetic acid. So we need to multiply by the weight of acetic acid. 1 mole acetic acid is CH3COOH 1 2 carbon, 4 hydrogen, and 2 oxygen. 2 times oxygen. 2 carbon is 24, 4 hydrogen is 4, and 2 oxygen is 32. 4, okay, then 60 grams per mole times 60. So it's 62.244 grams acetic acid. So here, first you have to get the moles from each liquid, then add them together, then convert the moles into acetic acid. A material has a mass of 368 and contains 0.92 moles. Determine its molar mass. So moles equals mass over molecular weight or molar mass. Since it's 9.20 and we know the mass, 368, all we have to do is to perform a bit of algebra. X equals 368 over 9.20. X equals 40 gram per mole. Okay, you need a 0.2 m aqueous solution of potassium nitrate with a total volume of 3.2 liters. How many grams of potassium nitrate is required? Okay, so 0.12 moles is 0.12 moles per liter. There is 3.2 liters. How many moles is needed? That is 0.384 moles. 0.384 moles. It's a potassium nitrate. Potassium is 39 times 1. Nitrogen is 17 times 1. Oxygen is 16 times 3. 39, 17. Nitrogen is 17, right? Well. 16 times 3. 48. Let me check. Nitrogen MW. Is 14. Sorry, it's 14, not 17. So the total molecular weight for potassium nitrate is 39 plus 19 plus 48. That is 106 times 1 mole is 106 grams. 0.384. 40.70 grams. 40.70 grams. Write the forward rate of reaction. Okay, rate of reaction forward. So this is the forward reaction. KF. Okay, gawin ko equals para magandang tingnan. Rate KF NO2 then O2 plus O2. Remember that the subscript is based on the coefficient. Since there is two nitrogen NO, there is raised to 2 here. So this is the rate of the forward reaction. A compound has a measured half-life of 5.6 hours. Determine its degradation rate constant. So T1 half equals 0.693 over K. We know the half-life, 9.6. We know this is a constant, and we don't know the K. So K equals 0.693 over 5.6. That is K equals 0.12375 per hour. I'll take note of the unit of time. So if the unit of time is R, the unit of K is per hour. If it's in minutes, it is per minute. Okay, yun lang naman po. Next, a drug solution starts at 0.158 and drops to 0.031 after 72 minutes. Compute the rate of reaction in molarity per minute. This is easy. All you have to do, remember, to get the rate is the change in molarity over change in time. So 72 minutes has passed, so that is the change in time. 0.158 minus 0.031 divided by 72. The rate is 2.138 times 10 to the negative third molarity per minute. Next, using the balance equation, find the equilibrium constant of H if of H2 if iodine and HI. Okay. Find the equilibrium concentration. Okay. Okay, so was KEQ given? Parang hindi kaya to. Because KEQ is HI squared over I2 and I2 and H2. However, we don't know the equilibrium constant, so we can't find it. Okay, let's go. I'll return to this. Determine the pH of a solution of 6.8. Okay, we have pH, you have H. pH equals negative log H. pH equals negative log 6.873 times 10 to the negative 4. pH is 3.1628. Next, a 1.5, so this is HA, given the pKa, calculate the pH. Okay, pKa equals H squared over HA. pKa is 4 point, no, it's only Ka. So we have to find Ka first. So Ka equals 10 raised to negative log raised to negative pKa. So Ka equals 10 raised to negative 4.87. Ka equals negative 4.87. Ka is 1.3489 times 10 to the negative 5. So we have our details. 1.3489 times 10 to the negative 5 equals H2 over HA of 1.58 times 10 to the negative 4 molarity. So 1.3489 times 10 to the negative 5th times 1.85 times 10 to the negative 4th equals H squared. That's square root of that. So we could get H. So lalabas po ang ating H. 1.34 times 1.58 10 raised to negative 4. Square root of answer 4.616 times 10 to the negative 5th. So pH equals negative log H. pH equals negative log 4.616 times 10 to the negative 5th. pH equals negative log ans 4.3356. Pyridine solution has a pH of 9.18. What is the molar concentration of pyridine? Okay, so ang nawawala ngayon dito is HA. So pKa, let's get first Ka is 10 raised to negative pKa. Ka equals 10 raised to negative pKa. 5.25 5.6234 times 10 to the negative 6. Okay, so Ka equals H squared over HA. Oh, so we need to get H as well from pH. Okay, so H equals 10 raised to negative pH. H equals 10 raised to negative pH, which is 9.18. So H concentration is 6.6069 times 10 to the negative 10th. Okay, so we have Ka, we have H. All we need is HA. So HA equals H squared over Ka. HA equals H squared 6.6069 times 10 raised to negative 10 squared over Ka, which is 5.623 times 10 to the negative 6. Square this and divided by 5.623 times 10 raised to negative 6. Oh. Huh? Parang ang liit. Yeah, 6 point. Yeah. Why? Again. Six 6.6069 times 10 raised to negative 10. Answer squared divided by 5.623 times 10 negative 6. Yeah, what I got is 7.7629 times 10 to the negative 14 molarity. That's a very small amount. Okay. Last question. Calculate the pH of an ibuprofen solution if 2.80 grams is dissolved in 2 liters of water. 2.80 grams times molecular weight 206 gram per mole. This would get us moles. 206 0. 0.1359 moles. Okay, 0.1359 moles in 2 liters is 6.796 times 10 to the negative third molarity. So this is our HA. We have pKa as well. Let's convert it to Ka. Ka equals 10 raised to negative pKa. K equals 10 raised to negative. Negative pKa is 4.90. So Ka equals 1.258 times 10 to the negative fifth. So we have K, we have HA, all we need is H. Okay. Ka equals H squared over HA. Ka, we already have Ka. So Ka times HA square root of answer equals H. So 1.258 times 10 to the negative fifth. This is Ka multiplied by HA, which is 6.796 times 10 to the negative third. Square root of that is our H. Times 6.796 times 10 raised to negative 3. Then square root that. 2.925 times 10 to the fourth, negative fourth, that is our H. And we need to get pH. pH equals negative log this one. 2.925 times 10 to the negative fourth, negative log ans. So pH is 3.533. Yeah, okay, that's the pH. Okay, that's all for the review problems.